Hello everyone, welcome to this session on Azure Digital Twins in a nutshell. My name is Michael Mateev. I'm Microsoft Regional Director from Sofia, Bulgaria, also Microsoft MVP and certified trainer, focused on Azure last 10 years and also last 5-6 years I work a lot on IoT solutions. In this session, we will cover several topics. I'm aware that some of you knows details about digital twin concept, but we will go through some major points. We will also consider how we can use digital twins in IoT projects. We'll make some comparison between digital twins in general, like software as a service, and device twins, which is specific solution for IoT Hub. We'll have also overview around digital twins for different cloud platforms. We will consider also specifics in digital twins service, Azure Digital Twins service for current preview, comparing to previous one, and we'll have some demos. It is good to know some details about how exactly digital twins concept started. It is something which started nearly 20 years ago with one proposal for a product lifecycle management solution where specific approach to simulate original system was proposed from Dr. Michael Greaves. And it was the first step with similar concept. After that, this concept stay more popular for different solutions. Step by step, it stay popular for airspace and also for different industry domains. It is good to know several things about digital twins in the context of terminology. Digital twins can be used in different ways. We can have prototyping of physical or virtual systems. We can have real twin, digital twin of existing physical or visual or virtual solution. And we can have also representation of some aggregations from many existing instances. Regarding to this, we consider several terms like digital twin prototype. Usually we talk about prototype when we have a model before to have the real instance, physical or virtual. We consider digital twins instance, which is replica of existing origin solution. We also talk about digital twin aggregate when we have a twin solution which represents actually aggregation from many different origins. So it is something which is quite flexible like approach, and we can have for this concept also different implementations in different industries, different types of solutions. It is not only for Internet of Things, artificial intelligence, but last years, because of popularity of these systems and good options to have applications exactly in such kind of solutions, we have more and more applications of digital twins in IoT and related artificial intelligence systems. Usually, we say that digital twins is part of so-named mixed reality. where we have at the same moment representation of real solutions with some digital replicas. So it is something which we will see with some details in the next samples, where we can have such kind of implementations, in which areas. One of the popular areas is exactly smart energy. We have energy models for optimization. It is also concept very popular in construction and facility management. That's the reason to have application of digital twins for analyzing of complex structures. It is also possible to have more specific analytics like health monitoring of different buildings. It is possible to have materials testing and different kind of analysis. Digital twins can have application during the whole life cycle of one product. That means we are starting with design. During the design phase, we can use digital twins for prototyping, and we can have different simulations. I will consider that simulation is just small part of applicable areas for digital twins. After that, during the real original solution maintenance life cycle, digital twins continue to be applicable because we are able to see in the digital replica all changes which we have regarding to settings of the original system. We can have some changes tested and push back settings to the original system. So in such kind of way, it is possible to manage the performance and to have different kind of analysis of our solutions. It is also very applicable for areas like sales and marketing. In the current solutions, it is possible to have observability of already manufactured systems or some software solutions, virtual solutions, where we are able to have monitoring and testings, analysis of these solutions during the whole life cycle. If we go a little bit more deeper, digital twins platform actually is integration layer. We have mixed reality where digital twins help to have connection between smart connected products and digital twin services. Under digital twin services, we can consider solutions which are focused on analysis. We can have different kind of analysis, but systems which are mainly for analysis could have nothing related to specific business case. In between, we have digital twins, and actually this is the place where we are making the connection between original systems and different solutions for analysis, or I can say analytics and artificial intelligence. So this is probably the most important, which we need to know in advance about digital twins before to start. I would like to add also some details to clarify what is the difference between simulation and different approaches for prototyping and modeling versus digital twins. Simulation is a very popular like approach when we have some design or some analysis later, but it is not 100% the same like what digital twins actually offers. Because when we have simulations, actually we generate and manipulate data, but digital twins allow us to have bidirectional synchronization with the original systems. This is actually the most specific part which we have now in other solutions. I would like to give you another example related to modeling with so-named BIM, Building Information Modeling. It is popular approach for modeling of structures, and we have pretty similar functionalities during the design phase, but after that we do not use modeling approach to monitor and manage existing solutions. With digital twins, it is possible. We have the whole solution parameters and we have behavior. So it is possible based on any change in the original structure to have some events which will be raised also on the digital replica. We will be able to analyze different changes. We will be able to make analysis, to make updates if there are some requirements to change configuration, to make some updates, and after that we'll be able to let the original solution to accept these changes. So this is probably like concept, something which we need to know before to start with digital twins. And it is good to have a little bit more deeper understanding also around digital twins and IoT projects. As already we discussed, digital twin is mostly like integration between information systems and physical things, also virtual solutions as origin. And we are able to have in these digital twins actually specific behavior. We will be able to trigger specific activities which can let different services also to have data processing. But data processing is not actually responsibilities of digital twins like specific kind of analysis. Just digital twins are responsible to have replication and analysis and rising of specific events when we have some changes. This concept could be, of course, created without having a specific platform. We are able to make all these functionalities available in a traditional way. If we have some appliance, this appliance is sending some events to specific services. These services are raising some triggers. We have some data processing, and in another place, another part of our solution, we receive some notification. The difference is that such kind of flow is quite complex. To support such kind of flow, we will have, without specific platform dedicated for this, like digital twins, we will have higher complexity, especially if we implement this in custom way, like custom solution, without some framework available to support most of functionalities out of the box. So that exactly triggers the need to have solutions focused mostly on this, how to manage any changes from the original solutions, how to raise events based on these changes. These events, of course, can be routed in specific way, so we will have different flows where we will have some outputs. Outputs are related to some services for analysis, storages, where we can analyze the information and after that to have some changes. In the Microsoft world, and especially IoT, probably the first implementation, which is related to digital twin concept, is about so-named IoT hub and device registry. We have here device twins. Device twins is a simplified version of this concept, which is used mostly for device management. It is pretty important and pretty critical for Internet of Things to have such kind of functionality. And probably this is the reason most of digital twins implementations to start from IoT. Not always, but yes, we have quite clear use case which can be reproduced with relative simple implementation. Digital twins is a concept in general, but we will talk about Azure Digital Twins, which is managed service. Azure Digital Twins is software as a service available in Microsoft Azure. Nowadays, we have already second preview in 2020. The first one was released in 2018. And regarding to my experience, this is probably the only one digital twins implementation which is software as a service accessible for any kind of clients without specific target like vertical solution, which can be used for multiple purposes. All other solutions which we have worldwide are not so easy to use, or they are focused on specific domain regarding to business and vertical solutions. We have in digital twins several things in the context of Azure Digital Twin Service which are implemented. We are able to get the power of spatial intelligence graph, which is available in Azure to have modeling of different objects. We are able actually to use different functionalities around IoT to manage IoT devices, to ingress data, and to have observation of the actual state of one complex systems. One of the very interesting and important thing is role-based access control and multi-tenancy. Especially in Internet of Things, we faced last several years that multi-tenancy and role-based access control is quite complex to be supported without implementation related to platform like digital twins services. And probably the last thing, which is very important, is rich integration. What I mean about rich integration, we are able, using Azure Digital Twin Service, to use different inputs from popular Azure services, like, for example, IoT Hub, and to have different outputs. We are able to configure endpoints for outputs and to set up routing of our events in digital twins service. Let's clarify a little bit more details about device twins, because again, you will be able to see many materials related to device twins, which is actually digital twins, but very, very simple implementation. Using IoT solutions, we need to have management of IoT devices. When we manage IoT devices, very important use case is to have devices up to date regarding to software updates and some configurations. And this is probably the simplest example where we are able to have from one side configuration, which is actual configuration in the device. This is the original configuration. And we have desired configuration, which is actually something which is configured from the backend. So when we have updates for IoT devices, always the concept is to try to make the same actual configuration and desired configuration. And usually devices make comparison between two configurations and pull updates. This is one of the possible options. Sometimes we have, of course, opposite strategy where push is from the backend, but the most important is that we have really very clear use case here with desired configuration and actual configuration. It is good to know what we have worldwide around digital twins, real digital twins. The difference between specific cases, like device twins, for example, is that these cases actually solve very small specific case. Digital twins in general should be a platform adaptable for different cases and we can configure it for different kinds of solutions. Main cloud providers notified that they support digital twins, but it is not exactly true because different implementations for most of providers are related with a lot of custom implementations. So digital twins related to other clouds like GCP, for example, are not based on one common service as we have in Microsoft Azure. It is just set of recommendations how you can configure your solution which will implement similar functionalities, but you have not ready for use solution. You need to have implementation and it is not something which could be done immediately. It is needed to have development cycle, additional time to be ready to market. In general, this is a case for most of cloud providers. Even in AWS, we have quite similar situation. AWS has similar implementation specific for device configurations, so named IoT device shadows. It is pretty similar to IoT Hub device twins, but on more general concept where we have already some general solution similar to Azure Digital Twins. We have no competitive solution. AWS offers set of services which can be used, services for analytics, services for IoT, services for storage, services for modeling, but not digital twins platform which can be used like software as a service. So this is probably the most important. And regarding to device configuration, where we have in both platforms, AWS and Azure, specific simplified solutions, we have quite similar behavior. But again, you have nothing like Azure Digital Twins service, which can be used in a simple way for other cloud providers. Sorry. It is very important to have these kind of relationships between digital twins and Industry 4 and 4.1, because digital twins allows us to automate processes, which is actually Industry 4, and Industry 4.1 means that we can automate our processes in easy and customer-friendly way. So digital twin service is exactly what you need for this. First release of digital twin service was 2 years ago, and most of the important functionalities are available till this moment with, of course, development and growing in the right direction for the last preview version, which was released in May this year. What we had in the first preview version, we had digital twins service on top of IoT Hub. And digital twins is used also for vertical solutions like IoT solutions accelerators, which you can download and customize, and Azure IoT Central. The case was that you have IoT Hub in the core of digital twins, but it was not actually decoupled, and it was not possible to have full access to this IoT Hub. In many scenarios, real scenarios, we need to have IoT Hub, which is separate, and to have some digital twins which works without need to have internally IoT Hub. And it is something affected in the latest version. If we consider Microsoft IoT, Azure IoT Blueprint, we have several areas where digital twins can fit, as you see. From one side, we have simulation and visualization. It is something which can be done pretty good with digital twins. Cloud Gateway, this is the service which is in front of other services, and in Azure by default we have IoT Hub, was a place where we had in the first preview digital twins with IoT Hub internally. It was possible to be used as IoT Gateway, but it was something which actually is not so flexible, and nowadays this implementation is separate. We have, from another hand, business integration layer with other solutions, very important because we can integrate IoT core services with different solutions for different kind of analysis or other enterprise solutions. And one of the most important part is so-named common data model. You need to have, for most of IoT solutions, common data model, and in the past it was implemented based on custom development. But nowadays, we can use it, we can have it using digital twins service. In the latest preview from this year, we have some updates regarding to modeling. We will see in the demos. In the first preview, you needed to start with some semi-flexible model where we have some ready-to-use objects, and we were able to extend this structure with custom objects, but the focus was mostly on smart spaces and buildings regarding to the preset configuration. Nowadays, you are able to have any kind of models. You are able to define models, and you have no need to be stuck to any case of preset type of object description. We have more flexible topology. We can have almost any kind of relationship now. We are able to have pretty flexible call of Azure Compute in different way with Azure functions, with calls, HTTP calls to functions or any kind of services. And we are able now, with this decoupling between IoT Hub and Azure Digital Twins, we are able to have much better access to IoT Hub, including different scenarios, for example, related to device configuration management. We now have also better implementation regarding to alignment of security policies for the latest Azure Digital Twins to what we have for other Azure services. We have no specific implementation and specific behavior from the user experience also. So everything which we can have about role-based access control, good practices for other services, we are able also to have for the latest preview. There are some limitations because in Azure Digital Twins service, as any software as a service, we need to have some limits which allow us to be sure that this service will be not overloaded. So regarding to this, of course, there are limitations around API calls and number of some specific instances. Documentation describes this in details. We have not a lot of time to cover this, so I will go ahead, but you can see in details existing limitations in documentation. For most of models, you will not face any difficulties with current limitations, so you are able to configure quite flexible, good, rich models without need to have edge cases where to hit some specific limitations. And for modeling, now there is a language available, so named Digital Twins Definition Language, DTDL, which allow us to have description of any kind of objects which we need for real cases. You will see in samples how these objects are described. In object description, we need to add some mandatory properties, but in general, you can put almost everything additionally. And as I already explained, you can have input from IoT Hub, from APIs, from logic apps, which is quite important for different kinds of automations in the modern solutions. And you have also outputs supported out of the box with configuration of endpoints, plus, of course, calling of HTTP endpoints and Azure functions. We have also like sample applications, open source project, which is so named Azure Digital Twins Explore. You are able in the current preview to load models, to load complex solutions, which are described in advance using this definition language, and to push these models into digital twin service. You are able to change some things, you are able to query digital twin service, so it is quite a powerful tool. We had more limited viewer in the first preview, which were able to have visualization and some kind of navigation, but not to load additional models and to push it into digital twins service. Several scenarios which are able to be done with previews. Using the first preview, you are able, as I mentioned, to have digital twins also as a possible implementation for our gateway service, where is IoT Hub. Nowadays, we need to have IoT Hub and digital twins separately, but you can see some schemas. It is quite important to make differentiation. We have different kind of routing in Azure Digital Twins, which allow us, if you have some changes, to have described flow, how these changes will be collected and analyzed in specific outputs. And nowadays, with the current preview, we need to have connection between digital twins and IoT Hub, for example. For this purpose, we need to have Azure functions, usually to have some logic. It is possible also to have integration, direct integration. So this scenario, which you see here with Azure function, is one possible scenario, but we are able also to have data ingression from specific services, including, again, IoT Hub, logic apps, and custom services based on configuration. And we are able also to have output to specific endpoints in a similar way with configurations. If we have real world scenarios, event routing is very important. Usually when we have such kind of structure of real solution in our spatial graph, we can have changes in specific object, which can be represented like node in our graph. This change can rise event, which is configured in specific way, dispatched, and it can be collected from specific services. Based on what we have for event consumptions, we are able to write custom logic and to make updates into our digital twins structure. This is actually the most popular scenario as a major approach to manage some changes using Azure Digital Twins. We have event routing, and based on any change, we have a common flow how to collect information from events and how to trigger some changes. We will see a little bit later real life solutions where we can have information from sensors. This information via IoT hub is sent to our digital twins service. The current case we're using Azure Digital Twins, and the output there is event grid. This event grid, based on what we have generated as events, is calling different Azure functions which do some changes. This is the flow which we will consider. Modeling looks in a similar way like this schema. We will see now samples. We have specific properties which need to be always available. We need to have ID. We can have for specific component also different versions. We have specific context, and in the context we have specific properties. Most of the scenarios which we can cover I already mentioned. One of the most important, at least from my experience, is device configuration management, where we have device monitoring, device provisioning, software update, and digital twins can be used for very good modeling of multi-tenancy in the context of device management, plus in the context of role-based access control for IoT hubs, again, around device management and matrix structure of organizations which are responsible for maintenance of different devices. Some real-world solution like this one, which is from the automotive industry, we can have a solution where for device configuration management, we can have digital twins as common data model. And any update of our configuration will actually be affected here. So we will have common model where each change will be actually reflected. It is something which is very useful, very handy, but you need to not forget one thing. Digital twin service is not a database. It actually has state of your solution with specific settings. But if you want to have some historical data with different states for future analysis, you need to consider some storage or database where you can persist your models state by state. This is probably the most important. There are good scenarios which we had also based on real use cases where we have digital twin service with connection to cognitive services, and we can provide specific analysis. For example, anomaly detection. This is one of the cases which I really like. We have implementation with the previous preview, still not updated with the latest one, so I'm not able to demonstrate it with the latest one, but I'm able to probably demonstrate updates pretty soon. So now it is time for some demos, and I will try to change the sharing. Just I will need a few seconds to have my Azure management portal available. And now I'm changing the sharing. So give me 1 second. Yes. Okay. So this is one subscription where we already have several services. I will make some filtering to show you what we have like digital twin services. We have nowadays two types, Azure Digital Twins Preview, the current one, but you can see already existing solutions as digital twins deprecated. This is the previous one. There are some differences and of course many similarities, but what is important to know here? You have important parameters like host name. You need to have also some settings related to access control. And I will show you different assignments here. Usually we can have for role-based access controls real users, apps registered in Active Directory, and yes, in the context of this also app service, for example, like function app, this is one of the scenarios. But one of the important things which you can see that you have one specific role, Azure Digital Twins owner, in brackets preview. So to be possible to have some specific functionalities available for your user, for your credentials, sometimes it is needed to have assignment using such kind of specific role. And we have, let's go to our Active Directory. Applications which are registered there to be possible to use credentials for access from different client applications. So here I have actually some settings. I registered two different applications which we use in our samples. You need to have for these applications specific API permissions. So for API permissions, you need to add for Azure Digital Twins read-write permissions. Also, you need to have, depending on credentials which you will use to log to your digital twin service with your application. Also, you can have some restrictions. Let's go to some examples. You can see in GitHub and also in documentation several ready-to-use samples, which are very good to represent initially exactly main functionalities around Azure Digital Twin service and available frameworks. You need to use SDK if you have, for example, .NET applications. Well, probably I didn't explain it a better way. You can use directly API calls, but in case if you want to have easy for implementation approach, you can use .NET, for example, solution with Azure Digital Twins related libraries, which you can actually refer. You need to have parcel, authentication, and several other libraries. If we start this solution, we already in advance need to have credentials, or these credentials, of course, in real solutions can be set up in more professional way in Key Vault and to be loaded at runtime. But if we have such kind of scenario, I will show you here. We need to have authentication. For authentication, we are going the authentication with Azure Active Directory, and we all have after that these options to have calls against API. I already did this one time before this presentation, so I have still available tokens here. You from the last time, so I had no need to log in my with my password. You can have here several options to see what you have. For example, get models to see all models which you already have created. But what means model? Probably this is something which is more important. So I will show you, give me a second, exactly what we have as model. And I will need few seconds just to open some example models. Let's do it in this way. I will open here some models. It could be with any editor. So digital twins definition language actually is a JSON, which represents structure as of the objects. You see that we have actually here specific things like type. We have several types which we can use, like interface, like property, like relationship, and we can add additional information, additional metadata in any kind of sub part of this model. How we can do the things in easy way, because we are limited with the time, and currently it is not possible to cover everything. I'm demonstrating Azure Digital Twins Explorer. Azure Digital Twins Explorer is actually Node.js application using React, which we can have to load models, update models in our digital twin service, and also to edit manually via interfaces. So let's load one of the preset models. This is model we described in Excel spreadsheet, and we are able to save this model, if it is not saved, into digital twins service. So you see that we have imported 49 digital twins and 50 relationships. Additionally, you can load descriptions of different objects done in this digital twin definition language. So when we have such kind of solutions in digital twin service, we are able also to query the service. I already loaded several models. That's the reason to see more than one models in our digital twin service, and you are able to have filtering. You are able to also edit your data for specific components. Unfortunately, we have not enough time to go deep in details how it works. I have end-to-end scenarios with device simulation, IoT hub, and real analysis via digital twins, which I will be able to provide after this presentation for all attendees. But we are almost up to the schedule. So I would like to see if we have some questions. If there are some questions, I will be glad to answer. Yes, there are questions related to AWS IoT and Amazon Cimmerian. I can explain the things actually. From one side, well, Amazon Cimmerian is for 3D modeling, but integration is not done in somehow out of the box. It is done with some recommendations how in AWS you are able to integrate these services. Regarding to Azure Digital Twins, there are the following possible options. Based on the API, you are able to have any kind of modeling client. This Node.js with React application, Azure Digital Twins Explorer, is one sample. There are two industry companies providing commercial clients. Bentley provides clients, and ANSYS provides clients. It was part of information which is referred in documentation for Azure Digital Twins. Probably there are some specific other custom solutions, but You are able to have integration with any modeling solution if you have, of course, additional custom development because API is public, well described. But if you want, you can consider also modelers for ANSYS or Bentley, and you are able to model your solutions in this way. For not very complex solutions, for something like this, you are able, of course, to rely on some sample implementation like Azure Digital Twins Explorer. I hope that I was able to answer to these questions. Do you have other questions? If you have no other questions, I'm very glad that you spent some time for this session. So thank you for attendance. I will provide additional information, and anytime you can contact me in social networks or via Microsoft if you want to have some discussions about specific cases around digital twins. I work on digital twins and especially Azure Digital Twins, probably year and a half, almost from the beginning, and hope that I have quite good experience. So I will be glad if I'm able to help you. Thank you and have a nice evening or day, depending where you are, of course.